Hello everyone, I'm N. Mahalakshmi from IT A section. Today I'm here to explain about the 32-bit Intel 80486 microprocessor. Let's get on to the topic. Firstly, we are going to see a small introduction about 80486 microprocessor. It is a 32-bit processor and the 32-bit 80486 is the next evolutionary step up from the 80386. One of the most obvious features included in a 80486 is a built-in math coprocessor. This coprocessor is essentially the same as the 80387 processor used with the 80386, but being integrated on the chip allows it to execute math instruction about 3 times as fast as 80386 387 combination. 80486 is an 8K byte code and has data cache. To make room for the additional signals, the 80486 is packed in a 168 pin. Let's move on to the next slide. Here we can see the simplified block diagram of 80486. This diagram has bus interface unit, cache that has 8K bytes, paging unit, segmentation unit, register and arithmetic logic unit, prefetcher that has 32-byte queue, decoding unit, control unit, floating point unit. Next, we are going to see the architecture of 80486. The architecture of Intel's 80486 can be divided into three different sections such as bus interface unit, execution and control unit, and floating point unit. The bus interface unit. Bus interface unit is used to organize all the bus activities of the processor. The address driver is connected with the internal 32-bit address output of the cache and the system bus. The data bus transceivers are interconnected between the internal 32-bit data bus and system bus. The write data buffer is a queue of 4 80-bit registers and is able to hold the 80-bit data which will be written to the memory. Due to pipelined execution of the write operation, data must be available in advance. To control the bus access and operations, the following bus control and request sequencer signals are ADS, that is address data strobe, WR, that is write and read, DC, that is data and control, MIO, memory input output, PCD, that is page cache disable, PWT, page write through, RDY ready, LOCK lock, PLOCK pseudo lock, BOFF means back off, A20M, that is address bit 20 mask, BREQ burst request, HOLD hold, HLDA hold request, reset, interrupt, NMI, FERR and IGNEE are used. Next, we are going to see the execution unit and control unit. The burst control signal updates the processor that the burst is ready. This signal works as a ready signal in the burst cycle. The blast output shows the previous burst cycle is over. The bus size control signals, that is bus size 16 and 8, indicates dynamic bus sizing. The cache control signals KEN, flush, a hold and EADS are used to control cache control unit. The parity generation and control unit generates the parity and carries out the checking during the processor operation. The boundary scan control unit of the processor performs boundary scan test operation to ensure the correct operation of all components of the circuit on the motherboard. The prefetcher unit fetches the codes from the memory and arranges them in a 32-byte code queue. The function of the instruction decoder is to receive the code from the code queue and then decodes the instruction code sequence. The output of the decoder is fed to the control unit to derive the control signals which are used for execution of the decoded instructions. Before execution, the protection unit should check all protection norms. If there is any violation, an appropriate exception is generated. The control room stores a microprogram to generate control signals for execution of instruction. The barrel shifter is used to perform the shift and rotate algorithms. The segmentation unit, descriptor register, paging unit, translation look aside buffer, and limit and attribute PLA are worked together for the visual memory management. Lastly, we are going to see about the floating point unit. Flag register of 80486 are status flags, carry flags, party flag, auxiliary carry flag, zero flag, sign flag, overflow flag, control flags, trap flag, interrupt flags, direction flags. It also has nested task IO privilege. The floating point unit and register banks or FPU communicate with the bus interface unit under the control of memory management unit through a 64-bit internal data bus. Generally, the FPU is used for mathematical data processing at very high speed as compared to the registers of the 80486 processor are same as the 80386 processor except for the flag register. As compared to the flag register of 80386, the flag register of 80386 has only one additional flag called alignment check flag or AC flag. The D18 position of the flag register is AC flag as we can see in the picture. When the AC flag bit is set to 1, there is an access to a misaligned address and an exception fault will be generated. Here we came to the conclusion. In this topic, we discussed about the simplified diagram of 80486 and the architecture of 80486 microprocessor. In the architecture of 80486, we saw the bus interface unit, execution and control unit, and lastly, we saw the floating point unit. Thank you everyone.